special product, because of the cubed, of course, I expect to get a binomial times a trinomial. I always establish the sign so I never have to worry about it. The negative, and the plus. The last one is always plus. You don't ever have to discuss it. So what do we get?
5x.
5x.
Not sure what that one is.
Let's take a look. That's okay. So we go to the calculator, and I have 216. You know how I like this, 1/3. And I get 6. So this is 6y. The trinomial is very easy. Square the first term, 25x squared. Square the last term, 36y squared. And then multiply 5 by 6, and we get 30xy. Okay, 2 more, and then we can start the trinomials. So x to the 6th minus 729, y to the 3rd. Descending order, yes. Greatest common factor in both, no. Negative leading coefficient, no. Binomial, yes. Special product, well, because of the power 3, of course, I can only think of a trinomial, of a difference of cubes. I have to establish the sign right away. The minus directs a minus, and the plus and the plus. Again, minus minus plus, plus plus minus, minus minus plus. When we ever talk about the last one, this is always positive. So which term we square to get x to the 6th? I'm sorry, which term we cube to get x to the 6th?
X squared.
Yes. Now let's put in the graphing calculator 729 and take the cube of it.
I think it's 7. No.
729 and the power 1/3.
I'm going to go with 8.
Close. So it's 9y. Once we identify the binomial, the rest is a piece of cake. We square the first term. We square the last term. And we just multiply them. 9x squared y. Is this okay? Okay, so let's look at the last one. This one. Z cubed plus 1 over 125. Descending order, yes. Greatest common factor, no. Negative leading coefficient, no. It's a binomial, special product, I hope. And because of z cubed, I hope for a binomial times a trinomial. I always establish the sign first, so I don't have to worry about it. So this is positive. So this must be positive. In the middle must be negative. And the last one positive. So what do I cube to get z cubed, and what do I cube to get 1 over 25?
Z 1/5.
Z and 1/5. The trinomial is a piece of cake. I square the first term. I square the last term, and I just multiply the two terms, and it's done. Do you think that we can move away from binomials for now?
Yes.
Okay, so we finished. There is nothing else I can teach you about binomials. This is it. So we look at trinomials. So these are the most cumbersome. These are the most cumbersome. Long procedures, many steps. Okay, so let me share my screen. and go to the flow chart. The few steps, the first 4 steps are identical. I'm not going to even write them again. I'm just going to say 1, 2, 3, 4. The descending order is mandatory. The greatest common factor out is mandatory. The negative leading coefficient out is mandatory. And then you're going to say, what is it? And now the answer will be a trinomial. Next, the first 2 special products are very nice and clear. The first term squared minus 2 times the first times the second plus the second term squared. We studied these 2 since last week. What we haven't studied yet are the last 2 options. The one before the last is friendly. The last one at the bottom is not. What is the difference here? We're going to talk about each and every one of them. But what is the difference here? Notice the leading coefficient in the one before the last is nice. It's 1. I should have not even written that in there because x squared means 1x squared. But I wrote it because I want you to understand the difference between these 2. If the leading coefficient is 1, we have to use this method. If the leading coefficient is not 1, we have to use the last one. Okay, so let's start from the beginning. Again, please understand this is the most complex situation, factoring trinomials. Okay, so number 1, descending order. Number 2, greatest common factor. Number 3, negative leading coefficient. So descending, greatest common factor, and negative 1. These are the same. And number 4 is what is it? And you have to say trinomial. Now what follows next are 3 different steps that we have not used before, none of which we have used before. In step number 5, special product. And we know 2. We know the a squared plus 2ab plus b squared. We know where this is coming from. We know it's coming from a plus b everything squared. We know where the next one is coming from. It's coming from a minus b everything squared. We discussed these special products last week. However, for trinomials, there is step 6 and there is step 7. In step 6, we're going to factor x squared plus bx plus c, specifically 1 as the leading coefficient. If 5 and 6 are not applicable, then I'm hoping that the last method is applicable. If not, I will say the polynomial, the trinomial is prime. If nothing works, then it's prime. Okay, so let's start with examples for trinomials. First from my handout, and then we move on to whatever else. Here it is. So we're going to start with y squared plus 121 minus 22y. Okay. Well, it's not in descending order. From the very beginning, I have to do some work. So this is now y squared minus 22y plus 121. Do all these 3 terms have a common factor? No, they don't. Is the leading coefficient negative? No, it isn't. Descending order? Now it is. Greatest common factor? No. Negative 1 as the leading coefficient? No. What is it? Is a trinomial. Good. Now I can only hope for a special product. So what I am going to do is what we've been doing so far, meaning If it is a special product, it can only be the second one. How do I know? Because only the second one has the middle term that is negative. Okay, so if it can be the second one, then I have what term squared is y? Well, I have y. What term squared is 121? Well, I have 11. However, this is good only if the middle term of this is negative 22y. If it isn't, these two are not equal, and this is not the factored form. But remember from last week, how do I get the middle term here? 2 times the first times the second. 2 times the first. Oh, sorry. 2 times the first times the second. So 2 times the first times the second is indeed 22y. Therefore, I can confidently say this trinomial can be factored as y minus 11 everything squared. It takes 5 seconds to verify using the formula from last time. The first term squared minus 2 times the first times the second plus the second term squared. Any questions on this problem? Anyone? Any questions on this problem? Okay. Moving on to negative 3x squared minus 12x minus 12. Please do not ever skip. Now, once you get used to it, it will only take a few seconds to go through the first 5 steps. Descending order, yes. Greatest common factor, yes. I have to pull it out. Negative leading coefficient, yes. I have to put the negative sign together with the greatest common factor. So what will I pull out?
Negative 3.
Very good. Now, careful what you put inside. We started with 3 terms. We have to have 3 terms in parentheses. So, what is left in parentheses?
X squared plus 6, no, 3, no, 4.
Good, good. Plus?
Plus 4.
Indeed. So again, descending order, yes. Greatest common factor, yes. Negative leading coefficient, yes. What is it? It's a trinomial. I hope for a special product. Because everything is positive, I hope for this special product. So then, look at the first and the last term and identify what we should have in parentheses. X plus 2. Only if the middle term here, which is 2, times the first times the second, only if this middle term is the same with the middle term here. If it isn't, then the factor form is incorrect. But it turns out that the middle term, as we discussed last week, 2 times the first times the second, is indeed 4x. Therefore, confidently I will say that this is the factored form of this. And the left-hand side equals the right-hand side. Any questions? Well, of course, we are practicing number 5. We're practicing number 5. So we did not get to these situations because our examples stopped at 5 by applying the special product. Of course, we're going to get to this in a moment, but I want to practice two more. Okay, like x squared minus 4x plus 4. This is a very simple one. And that's my page 7. So x squared minus 4x plus 4. By now, you should be able to come up with the answer quickly. But if not, it's okay. Descending order, no greatest common factor, no negative leading coefficient. This is a trinomial. Special product. Only because the first term and the last term are perfect squares, I can say x minus 2 squared. Otherwise, I will not be able to. But the first term is a square, a perfect square, and the last term is a perfect square. But what I haven't checked is the middle term. I cannot just move on and just write x minus 2 squared. No, 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 no. I have to check the middle term here, which from last week we know it's 2 times x times 2, which is 4x. Of course, minus. If this one is the same, then I'll say yes. If this one is not the same, then I'll say no, 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 this is not the factored form. Do we understand this? Okay, last one, a squared plus 6a plus 9. Can anyone walk us through this? Descending order, yes. Greatest common factor, no. Negative leading coefficient, no. Special product, I always have hope for the special product, especially when I see perfect squares. So what do you expect this to be?
A plus 3.
Yes.
Or a plus 3 squared.
Perfect. But we have to check if 2 times a times 3 is identical with this middle term. Because if it isn't, then this is incorrect. Well, it is. So I will say yes, it's correct. Okay. Do we understand the special products in trinomials? There are only 2. In binomials, we have 4. In trinomials, we only have 2. Can we move on to the other 2 techniques? Okay. I'm very concerned that nobody answers other than a couple, Matt. So I'm really concerned if anybody understands this or can follow it. I hope you can. It's a mistake that you're not saying anything. Okay, maybe you will. Okay, so now we are finally getting to this type. This type means a special product is not applicable. Okay, so I'm going to start with the first one to explain the method. Squared plus 13m plus 42. Okay. It's a trinomial. Descending order, yes. Greatest common factor, no. Negative leading coefficient, no. Special product, no, because 42 is not a perfect square. This is a perfect square, but this isn't. So I cannot use a special product. Is 1 the leading coefficient? Thank goodness it is. So here's how I think from here. Now, let me give you a simple example. If I have x plus 1 times x plus 2, what happens here when I FOIL? X times x is x squared, plus x times 2 is 2x, plus 1x is x, plus 1 times 2 is 2. So when we combine like terms, we have 3x plus 2 and x squared. So notice what happens. This number is the product of these two. So we're going to call it the product. This number, notice, is the sum of the same two. Again, So when we look at this trinomial, this number comes from the product of these two numbers. And this number comes from the sum of these two numbers. So this piece, this number right here, is the sum of two numbers we need. And this number with the sign in front, that's why I took the signs in there, is the product. So what I'm saying to you is the following. We need to find two numbers whose product is 42 and whose sum is 13. Again, we start with the signs. If the product is positive and the sum of these numbers is positive, the numbers must be positive. Both. So now I have to think of two numbers, same two numbers, whose product is 42. And when I add them, the same numbers, I get 13. And that is the final answer. And you'll see how we are going to write it. Can anyone give us two numbers whose 7 and
6.
yes, m plus 7, m plus 6. Written in any direction you want, m plus 6 or times m plus 7 or m plus 7 times m plus 6.